Hey everyone, this is Mr. Zeer again. So in today's video, it's all about how to undervolt your Intel CPU for cooler temperatures using XTU. So we are going to use the Intel Extreme utility for us to get optimal CPU temperatures. So first, you just need to know the main PC where I'm creating this tutorial from. It's an Intel Core i7-9700K. You can see there, it's a Intel Core i7-9700K CPU. It can be overclocked to 4.90 GHz. So this video is tailored for Intel users, and you can see very well I'm using, as I said, Core i7-9700K CPU. So what we'll need to do first, I just want to show you guys, you are going to need to download this XTU, the Intel Extreme utility, from their website. So you can click on my article on step 1 there, and you will get this tool, you see. So you're going to just click download. After you have downloaded the XTU, this is how it will look like. So you can see right now I've reduced my core ratio from 47x, which by default, let me revert them to default. You can see they are playing at 46x, which is equivalent to 4.6 GHz. You get 4.60. So right now you can tell my PC it's at idle state. Yeah, so I'm using an AIO. Yeah, it's a AIO that I'm using. My case is a Lee case, so I have a good cooling system. But still, with this core ratio, trust me, we can hit 90 degrees pretty fast. Yeah. So what you need to know first, so you just need to go to your Windows and click Power. So you're going to choose a power plan. By default, you will get your PC. Maybe you might be using high performance, power saver, and so on. So make sure you're using automatic, balanced, which is by default is I think, yeah, you just select balance, because you need to know when it's at balance, your CPU won't be drawing a lot of power, because when you're on a high performance, it tends to give the CPU a lot of voltage, you get. So what's next? So what you need to know, on manual tuning on this Intel Extreme tuning utility, the XTU, that I will be using that name. This XTU, it has some advanced view stuff that are for those advanced users, but I will advise you not to use that. So you just need to click compact view. So you are going to see performance core ratio. So for us to really do some good test, we are going to use this run bench. We are going to try using their run benchmark tool, and then I'm going to open one game so that we can test using a game. I think using a game which will be better. Yeah. So right now we are going to start with 46. So what we need to do, we just need to run a benchmark, and I don't want to start touching the core voltage offset right now. So let us do a benchmark, and you are going to be checking these performance from the taskbar here. I want you to be confirming while I'm doing some benchmarks. Yeah, like that. Let us remove OBS. Yeah, so we're going to start with that one, run a benchmark. So you can see right now our temperatures are rising to 88 degrees, 92, 96, 100. So I will stop. You see, there's no way I can leave it at 100 degrees. So you can see 46x it's not the optimal core ratio that you are going to choose. So what you need to do, you are going to start reducing them slightly. So first, can we just start playing with the core voltage offset, and then we're going to touch the performance core ratio later, or we deal with the performance core ratio first and then we're going to combine later? So like right now, we are just going to avoid core voltage offset and deal with performance core ratio. So I'm going to also reduce again. So we're going to start with 43, apply, 93 degrees, 92, 94, 95, 94. So you can see with the 4.3 GHz, Right now you can see it's playing at 4.3 GHz up there at max. It's at 100. Let us stop it. So still 43 is not that it can cause your CPU temperatures to rise dramatically. So let us again reduce them further. So let us go with 41. Yes, so it has 4.1 GHz. The one thing that I need to use for you to be able to track those the CPU power output. So we are going to need this tool called temp. So I'll put the link on the description also. You're going to install this software called temp. Yeah, like that. This one will be better for you guys. So I think you can see the CPU and that one there, like that, so that you can monitor this stuff very well. Okay, nice. Virtualization is off. So let us go. Let us do another benchmark. Yes. So right now we are at 4.1 GHz, and it's using voltages. You can see it's using 1.1, 1.2. So remember, we are moving to this area for where we're going to do some voltage reduction, undervolting them, Okay, so you can see right now we are at 82 degrees, 84. Confirm. So you can see core 4, the fourth core is and the second core, they are hitting 72, 80 degrees. So right now the average I think it went to around 82, which is not that bad now for your CPU's lifespan. So we are going now to start I think let us go further. So I'm going to go with 38 now, apply, and then the final one we will try. Let us start with 37. In fact, yeah, 3.7 GHz. You can see by default this CPU is supposed to be running at 3.60 GHz, but we were trying to overclock them at least so that they can perform with the higher GHz. But you need to know, the more GHz, the more power it draws from your power supply. Okay, so we go on now. We do another run benchmark. So you just need to confirm the voltages here. Now they are not at 1.1 something. It's using 1.0 something, 1.0 something, and the temperatures are now at 66 degrees average. I can say it will maybe stop at 70 something. Let us confirm. You get now. So you just need to know, when you want your CPU's lifespan to be optimal, kindly always, it's advisable to not overclock your CPU. I've always been saying that it's not that good. It's not something that good. And by the way, I don't usually see any huge difference for those ones who have overclocked. Even for those ones who are using heavy cases, heavy good cooling system. Sometimes, in fact, these normal Lian cases can even outperform them totally. Okay, so we at average, you saw we went to around 70, 60, I think you saw, yeah. So what we need to do, we are going now to start now dealing with the core voltage offset. I want to make this video to be short. I won't be explaining too much. So we are going to, I know most of you will just want to play with 40, maybe 44. Yeah, I will go with 40. Let us just start with where we were at 46. And then now we are going to start with the core. In your case, it's advisable to start with 20. I'm not sure if you like this video to be long. We can try both of them. So let us go with the difference of 30 then. 30, because mine can stop. Let us go with 25. Can they accept? Yeah, 25, because in my CPU I can go with core voltage negative 0.025 voltage, but in your case I'm not that sure. You are supposed to start with this one, a negative 0.025, which is ideally advisable. You know, many out there, they always say start with 0.010. Okay, so you are going to start with negative 0.025 and then click apply. So we saw that time we were ranging around 91 degrees. I wish I could have edited this video in segments, but I just want it to be raw so that you can see the optimal performance of this XTU in this Core i7 and 700K. Okay, so now right now we are at 4.6 GHz and we have undervolted the negative 0.025 voltages, and we have clicked apply. Now we are going to start testing. You can see 73, 78, 85. By now, at that earlier time, we could have hit the 100 degrees. See, stop. So we are going again to go down further, negative 50. Click apply. I hope you are keeping check on this VID. Okay, run again, run a benchmark. 4.6 GHz now with offset of negative 0.050 voltage. Now we are at 93, 97, 100. You get? In short, with 4.6 GHz, even if you are undervolting your CPU too much, if you go too much, you know it will crash. So I did a lot of tests, so I know my CPU can just finally it can go at 100. So let me just go with 100 and save time. Apply. Right now we have removed negative 0.100 voltage. Now we need to okay, now let us do another benchmark. I hope it won't crash because I'm recording at 4K 60 FPS screen recording. 82, 86. Now it's using 1.1. Can see there it has 90 degrees. You can see it has tried, but still the temperatures might hit 100. We are very sure with that. See, stop. So it's a must. It will just hit 100. So if we now I'm not going now to touch anything there because you have seen my CPU can take negative 0.100 voltage. So we are going out with 44. Or 45 because I know many of you will just want to go slowly. Okay, now again we do another benchmark. $79, $81. It's using 1.1, yes. So it's 7 degrees. Remember we are at 4.5 GHz. You can see there, gigahertz. Okay, 90 degrees. You can see it has tried 92, not bad still, but it means this 4.5 is not that. It's still not the the one that can make your CPU to last longer. We're going now to stop. You can see under heavy load it can still hit 100 pretty easily. So stop. So we go with 44. Nice. Yes. Now we try. Run benchmark. It has 50 degrees. I want it to cool down. Nice. Now we do another one. 7, 79. So you need to know we are using a benchmark tool from XTU. But if you are actually playing a game, it might favor you even at 45x, and it might not even hit 80 degrees sometimes, because this benchmark tool, it's really taking all of the CPU. It's benchmarking, it's taking it to the core, you get? So just need to know that. Yeah, it might perform different while you are gaming. And we are going to test all of them. 93, 90. So average was at 93 degrees. We hit I think, yeah, we have just hit 93 degrees with 44x and negative in a core voltage offset of negative 0.100 voltage. So we go down still, we reduce it further. So let us go with 43. So you saw it was 93 degrees at 44x with a negative 0.100 voltage. So this is 43x. I said this video is going to be raw, so I hope you're maybe writing somewhere so that you can test on your own using your PC. Okay, so we're at 43x, which is 4.3 GHz. So let us see. 67, 70, 71, let us confirm. 84, 85, 86. So So I think it will just stop at 87 or at 86. So the average CPU temperature for 43X with the negative 0.100 using this benchmark tool from XTU, we just hit 86 degrees. So we reduce further. Now we go to 42. You can see they are making a very huge difference. Again, 71, 73. So let us see if this one will stop at 80 or at 81 or at 85, because the previous one was at 86 degrees. So the voltage it's using right now is 1.0379. So this one might stop at 81 or 80. Yeah. This one is 41, right? I think it will start to reduce. 83 on. Okay, so this one average. So we just deducted negative 3 degrees from the 43 one. So let us see if they are removing a difference of 333. Next, we are going just to jump now to 38. So that I make this video short. So let us go to another benchmark and see if it will stop at 79, 78. 78, 79, as I just said. So it seems each if you remove each point from, for example, 42 to 41, it automatically removes 3 cores. I mean 3 degrees difference. And while you are gaming, you'll see a very huge difference, by the way. So this one was at 80 degrees. So let us go to 38. So if you ask me which one I like using when I'm gaming, I might use 38, sometimes 40, final 41. Yeah. So apply. I like 37, of course. I know that 7 will perform better. No, I don't want. Do you guys want me to test with 3.6? Run benchmark. Now later, you see, right now it's not even jumping to 80. We are at 60, 63. And you need to know this XTU is taking a lot of CPUs. You can see average is right now is at 66. So guys, I think this video, it might be helping someone out there who might be suffering from high CPU temperatures. As gamers, we know how we don't like to see high temperatures while we are gaming. Yeah. By the way, there's a video I created recently, but I mixed it, I have explained. So I saw it will be better for me to create different videos individually. Okay, so this one you saw, it performed very well, and you can see the difference now with 37X and the higher GHZ. It's that the higher GHZ will take a lot of CPU power, which will result in higher CPU temperatures, and the lower GHZ, it will result on lower CPU temperatures, and especially if you have undervolted your power supply. Okay, so you can see right at that time we went to 59 degrees Celsius, which is not bad, right? Yeah. So that is it. Let me just go with 36 because many of you want to see 36. I've not tested this one, so disclaimer, the PC might crash. I've not tested that one. So let us see if this one it will hit how many degrees. Run benchmark. So it's now using 0.9. The temperatures are at 55 degrees, 57, 57, 59. So let us see. Okay, so this one just went to 63 degrees, 64 degrees, 65. So you can see the most average degrees when you are using these 30s is around 65, 67, which is the best CPU temperatures that you will like to have on your PC. Yeah. So this one it went to average, it went to 60. So according to this tool, it's around 59 degrees. So what we need to do now, I want to do some gameplay. I want to do some gameplays, and I want just it to be where it was at 0.00 voltage. And then we are going to start with 42, apply, and then I want to put a CPU hungry game like Red Dead Redemption. Yeah, so you can see right now we are in the game. We are in Red Dead Redemption 2. I finished playing this game recently, and it's one of the best games right now. Okay, so you can see right now we are at 69 degrees, and we are using 4200 mHz, which is equivalent to 4.2 GHz. You get? So our temperatures are at 69, 70 degrees, and when I take you to my settings, you can see I'm using 4K ultra everything. 4K ultra everything. You can see, you can confirm. You get? Those are my 4K 60 FPS settings that I'm using. So I will click apply. No, I haven't just touched anything. So you see our CPU temperatures are at 68 degrees, 71 degrees when we are using 4.2 mHz. Okay, so what we need to do, like we said that time, so we are going to start with our Undervolt, and I told you my CPU can take negative 0.100 voltage like that. Apply. So let us see if it will start to drop. We are at 69 degrees, 71, 69. 68, 67. Get, so let us try to, because let us try with 30. The lowest one, 37. Nice. Let us see 63, 64, 62. So you see, those aren't really bad temperatures at all. $60, let's say. Let me try to say 59. So the average temperatures that we are getting at 3.7 GHz and with the Undervolt negative 0.100, it's 59 degrees, which is not that bad. You get? So that's how, guys, you can really undervolt your CPU. Yeah, so you can let me know if this video helped you, and that is it for today's video. This is a very long video that was purely raw, so that you can understand and so that you cannot make such mistake that I was making. Yeah, sure. So let me know, and you can make sure to subscribe.